Okay, this is the last topic from Tuesday, 11/25. For those of you that came into class, we did this at the end of class, but I'm also going to do it here. So the formula, it's a weird formula, and I'll talk about where it comes from on Monday, but f of x, if we want to find the power series for f of x, this is the formula that we use. In other words, that is my AK. In other words, AK equals this. So I'm going to illustrate this for the sine, how you build a formula. And the sine has interesting properties that if you take four derivatives, you're back where you started. So f of x is notated as a zeroth derivative of x, and that's just sine of x. The first derivative of the sine is a cosine. The second derivative is minus sine. The third derivative is minus cosine of x. And if we take another derivative, we're right back to where we started with the sine. So this is also going to be the fourth derivative. Do it four more times, we're back, the eighth derivative, and so forth. And likewise here. That's the fifth derivative and the ninth derivative. Take four more, we're back. So it's going to also be the sixth derivative and the 10th. So we get this nice property and so forth. This will be the seventh derivative and the 11th and so forth. This continues. So it's going to go dot, dot, dot. Okay. Now what if x is equal to 0? Because that's what it says to plug in. I want f of 0. So if I plug in a 0 here, I'm going to get 0. If I plug in a 0 here, I'm going to get 1. So all these derivatives are going to be 1. Again, plug in 0, I get 0. And then 3. I'm going to get minus 1. So that's kind of a neat formula. Okay. So basically we're saying that even derivatives are equal to 0 for the sine. Odd derivatives at 0 are going to be equal to 1 or minus 1. Okay. So now I'm going to use this formula to build a series. So we'll go back to do this. So I'm going to say the sine of x is equal to a0 plus a1 of x plus a2 of x squared plus a3 of x cubed and so forth. Okay, here's my formula. So a0 is going to be f of 0. a1 is going to be the first derivative of 0 times x over 1 factorial. a2 is going to be the second derivative at 0, which we know is going to be 0, over 2 factorial and so forth. Third derivative, 0, and I'll do a couple more, do 2 more. a4 is going to be equal to this is a3, that's a4, a3, a2, and then this pattern's going to continue. I'll do one more, just so you get the, okay, so that tells me what to plug in, this formula. Get 0 whenever I get a 0 here, a2, well it's going to be f2, 0, f4 an even derivative, 0, and so forth. Well, f1 is going to be 1, so what we got here, over 1 factorial. f3 of 0, minus 1, over 3 factorial. So I have that one left. I have this one. Fifth one, this is going to be 0. The fifth one, I'm back to where I started, so I'm going to get 1 x to the 5th over 5 factorial. And I think you'll see the pattern. So I'm just going to clean this up a little bit. Let's see. I think we need that. Okay. So this is going to be equal to, so we're saying the sine of x is equal to x over 1 factorial minus x cubed over 3 factorial. Next term, plus x5 over 5 factorial. I bet you can guess the next one. X to the 7 over 7 factorial and it's negative because 7th derivative is minus 1. The next one, x to the 9 over 9 factorial, and so forth. And that's it.